Okay, guys, today for the asynchronous lesson, we're going to jump into finishing section 7.3 today. And it's we're going to get into, solving our first trig equation. Some of you might not think of this as an equation that we're solving, but it is. So the question is saying solve sine theta equals 1 for theta in degrees. So that's telling us that our angle measures should all be in degrees, and then we kind of have to break this down. So as a reminder from yesterday, one of the things we covered was that we're kind of looking at points on the circle for respective angles right now, right? So we have x and y. If you remember from the other day, we talked about the right triangles that we form, and we talked about how the radius or the hypotenuse of the triangle, the radius of the circle is 1, and then your vertical in the triangle is the y coordinate, and your horizontal in the triangle is the x coordinate. And then we also connected that the sine and cosine of that angle are equal to the y and the x coordinates respectively. So just kind of put that on the board here. The x coordinate, where the terminal ray of the angle intersects the circle, is always equal to the cosine of that angle. And then our y coordinate is always equal to the sine of that angle, right? So that's kind of critical information. You can kind of express it as a coordinate point if you like. Cosine theta is the x coordinate, sine theta is the y coordinate here. So the question that we're looking at is saying solve sine theta equals 1, right? Moving into the future, we'll work on ways to kind of break this equation down. This is more an intuitive, logical approach just by working with the unit circle here. So I don't really know much except the sine of the angle is 1. And if I think about the relationship right here, right, I know that the sine of the angle is equivalent to the y coordinate. And right now, the y coordinate is 1, right? So I can then kind of move around my unit circle. I'm going to get rid of this triangle here. And I'm going to look for, at what angles or where on the unit circle is the y coordinate 1, right? So remember, right here, we have a quadrantial angle where the coordinate point is 0, 1. Right here, I have another quadrantial angle where the coordinate point is 0, 1. Over here, I have one at 0, -1. And right here, down here, I have one at 0, -1. Excuse me, I wrote this coordinate incorrectly. It should be -1, 0. All right, so I can see right here that my y coordinate of this point is 1. And then I can look at that angle measurement, right? So this angle goes straight up, and this would be the angle we're looking at. That happens to be a 90-degree angle right there. Always trace all the way around the circle to make sure you've hit all the angles, because in some cases we have trig equations where there's one solution. Sometimes we have trig equations where there's 2 solutions. And then depending on the specifics of the question, we can actually have an infinite set of solutions here. In this case, as I kind of continue to go around my circle, I realize that there's no other y coordinates on my circle that are equal to 1. So in this case, then I'm going to turn around and say, well, then theta must be 90 degrees. Right? At this point, we want to call it quits and figure out that we're done. But keep in mind that we can continue to rotate around the circle infinitely many times, right? So that brings up the idea of coterminal angles. So my first angle I found was 90 degrees, but if I go one full rotation from that angle 90 degrees, I am now back at that same terminal ray, and my y coordinate of that angle is also 1 again. And if I go around the circle another full rotation, I end up at the same spot again, right? So this first blue angle that I drew would be 90 degrees plus 360 degrees, which would take us to a 450-degree angle, right? So then we can also say we have another angle that's also at 450 degrees, where the sine of that angle is also equal to 1. And I can continue to do this forever and ever and ever. And when we studied those coterminal angles, we kind of used a system. So what we can do is we can represent this for all possible values, and we can say, well, theta is going to equal 90 degrees plus 360 degrees n. And right now, where n is equal to an integer value. N represents the number of rotations from that 90-degree initial angle